Hello, Health Science 4502 students. This is Professor Van Dyke with your Week 8 video. And this is in regard to confined space gases. And you will have a lab on this, so make sure and do your lab for this week. And also make sure and do your lab from last week as well. Still waiting for a number of those. So I wanted to give you a little bit of information. Again, this presentation is going to be fairly short. The video will be fairly short because I wanted you to focus on your paper and your presentation as well. So make sure that you're ready for that. Make sure that you get started on the process. I know it's not due for a while, but make sure not to procrastinate on that so that you're prepared to write a really solid paper that's going to end up in your portfolio. Okay, so this week we're talking about confined space gases. And one of the reasons that this is so important is because we do work with a lot of equipment that will produce carbon monoxide, carbon dioxide, potentially sulfur dioxide, things of that nature that can be fairly challenging when working in a confined space. And certainly our big concern is that we end up in an oxygen deficient environment. So as you remember, you really want, you're not going to be using an APR style filter for this if you're in confined spaces that you may consider dangerous because of increased carbon dioxide, carbon monoxide, O2 deficient environments. An air purifying respirator is not going to work. You're going to want something that's actually supplying you with, generally what's going to be positive pressure oxygen provided through a respiration system. So with that, we'll go ahead and jump right into it. And again, very short in regard to the material, but this is something that I want you to know. Obviously, for the purposes of this course and for life in general, you don't have to memorize these things because you're going to be able to look them up. And again, this is just something that really gives us kind of a chance to talk about the critical confined space gases of concern for us. So kind of keep that in mind as we move through this very quickly. And again, there are only 8 slides. So moving on to slide 2. I just wanted to give you an FYI that the ACGIH values for this were taken from the 2014 threshold limit value and BEI book. Again, I put on here that you need to know all these values for the final, but really my finals are going to be a lot more you coming up with answers to essay-based questions. So these aren't the kind of thing that you're going to have to memorize. So I just want to kind of give you an overview of some of the important confined space gases in regard to what we're dealing with. On to slide 3. So with carbon dioxide, the ACGIH value for the threshold limit value, time weighted average for an 8-hour shift is 5,000 parts per million. And then the threshold limit value for short-term exposure is 30,000 parts per million for carbon dioxide, which is fairly high. But again, we're really still keeping worker protection in mind, keeping worker safety in mind. These are values that are acceptable, obviously, for the short-term exposure limit at 30,000 parts per million, which far exceeds the threshold limit value for the time-weighted average of 5,000 parts per million because it is a very short-term exposure, a 15-minute exposure, as you remember. And then we have the ASHRAE value, which is 1,000 parts per million in an indoor environment. And then, as you know, CO2 is a surrogate for proper ventilation indoors. So what's going to happen is the CO2 will actually displace the O2 and can be fairly dangerous. Obviously you've heard about people that are exposed to high amounts of carbon dioxide, carbon monoxide as well, that it will actually displace oxygen and cause people to pass out and potentially die from exposure to high levels of carbon dioxide and carbon monoxide. So again, with carbon dioxide and all these values, it's a guideline, and it's not an occupational exposure limit in general in regard to what you're seeing, because you're seeing ACGIH values. You're not seeing permissible exposure limits. You're seeing, so as you remember, these are guideline values. These are more like RELs as opposed to PELs, right? Recommended exposure limits, because they're coming from ACGIH. They're not coming from NIOSH. They're not coming from OSHA. Okay, so do keep that in mind, please. On to slide 4 with carbon monoxide. Again, you look at these values. So now we're actually looking at a cal OSHA value with a permissible exposure limit of 25 parts per million. Carbon monoxide can be very dangerous. And then your upper ceiling for exposure for carbon monoxide is 200 parts per million. And then you have the ACGIH values with the threshold limit value of 25 parts per million, which coincides with the permissible exposure limit from OSHA. And then there's no short-term exposure limit for carbon monoxide, which basically means that you do not want to be exposed to excessive carbon monoxide for any period of time. Now, this really becomes important when you're working around combustion motors that are producing large quantities of carbon monoxide. This can be extremely dangerous. A number of individuals have fallen victim to this, where you pull a car into a garage, you leave the car running, and before you know it, you're overtaken by carbon monoxide, and it basically feels like you're falling asleep, and you are not falling asleep. This stuff will drain the life out of you very quickly. This has happened to mechanics. One of the things that I heard of recently was that someone had a virtually silent vehicle that they were driving. It was a hybrid vehicle which burns fuel and also will use its hybrid capabilities through the electric motor. And what ended up happening was that someone fell asleep inside their car. The electricity component of the supply ran out. The vehicle switched over to its combustion engine. The individual was overtaken by carbon monoxide and ended up being fatal. So again, carbon monoxide can be very, very dangerous. On to slide 5 with hydrogen sulfide. Again, commonly produced in occupational settings, especially when you're dealing with combustion of any kind. So the cal OSHA value for hydrogen sulfide is the permissible exposure limit of 10 parts per million, and then a ceiling at 50 parts per million. And then the ACGIH value with the threshold limit value, time weighted average of 1 part per million, and the short-term exposure limit of 5 parts per million. So as you remember with carbon monoxide, there is no STEL, right? There is certainly a ceiling that no one should ever be exposed to these beyond that ceiling value, right? So the ceiling essentially says you never want to expose someone to hydrogen sulfide or carbon monoxide at a rate that is greater than the ceiling itself, okay? On to slide 6. So with oxygen, when we're talking about an oxygen deficient environment, an atmosphere essentially that's oxygen deficient is going to be at 19.5% or less. So as you remember with the air that we breathe around us, we're dealing with a lot of nitrogen. We're dealing with some carbon monoxide and dioxide naturally existing, but certainly the primary component is nitrogen, and then you have this small percentage of oxygen. So if you fall below that 19.5%, you're dealing with an oxygen deficient atmosphere, which can be very dangerous, because if you're not getting that oxygen, you know all too well the effects that it can have. So certainly if you've climbed to very high elevations like 14,000 feet, you know how challenging it is to just move around because it is oxygen deficient, not quite to these levels, but certainly as you get higher and higher, you will begin to run into more oxygen deficient atmospheres. That can be very dangerous for individuals, and it's one of the reasons why people that climb Mount Everest have to keep going back and forth, because they're acclimating themselves to much less oxygen actually in the air. So the NIOSH immediate danger to life and health value, this has the potential to be very life-threatening. And again, you want to avoid wearing these APRs, the APR respirators, so the air purifying respirators. They're not going to do you any good in an oxygen deficient environment because you need that oxygen. And an air purifier is not going to provide you more oxygen. It's just going to remove impurities from the air around you. So please keep that in mind. Something you need to understand when you're going into an environment and you're going into an atmosphere that you believe is oxygen deficient, you cannot use an APR. You need to have like a scuba style system that is providing you with oxygen, usually through positive pressure. Okay, so with normal oxygen in an atmosphere, you're usually looking at about 20.9%. So you can see that the difference really isn't that much, but it is very noticeable to a human being trying to breathe. If you're at 19.5 or if you're at 20.9%, there is a difference, and it is it can be noticeable, but again, uh, the difference is so minimal that there can be issues where you're at 19.5, you don't realize you're in an oxygen deficient atmosphere until it becomes a problem, and you possibly become incapacitated, and that can be very dangerous for you and for the people that are coming in to rescue you as well. So with oxygen excessive atmospheres, at 23.5% or more, the issue you have here is the potential for explosion. Because as you know, oxygen will burst into flames. And fortunately for us, a large percentage of the atmosphere upon which we live is primarily nitrogen, which is not going to burst into flames. So fortunately, you can walk outside and you can start a campfire without the air and everything around you blowing up, because we don't exist in an atmosphere of 23.5% oxygen rich environment. We're generally going to be right at that 20.9% with oxygen. And again, once it falls below 19.5%, that's where you start to run into issues. So this can occur when you're in a subterranean confined workspace. It can certainly happen in a building where for some reason oxygen is being depleted for some reason, and these are things that you really want to watch out for. They can be very dangerous. On to slide 7. So some of the confined space factors, and when we think about confined spaces, we tend to think of working working in an enclosed system, maybe pipes or tunnels, or it could be a very small room. There could be a lot of different things that are going on that are causing the oxygen to be depleted. So as you remember with the triangle for fire, one of the components that you need is you need to have that oxygen. You need to have a fuel source that's burning. You need to have an ignition, things of that nature that can potentially cause you problems. But certainly with confined space, we're looking at one of these different components being in play that can make this very dangerous. And we're currently on slide 7 right now. I apologize, I haven't been letting you know the slide advancements, but hopefully you're all on slide 7. So with factors for confined spaces, if you have one or more of these present, you're going to be running into potential health hazards for the workers or people that are exposed to these areas. So the first is lack of oxygen, and that can occur in a number of fashions. But certainly, when you think about being inside a mine, if you think about working inside of a small confined space in an underground, like an underground storage tank, even an above ground storage tank, these things can be fairly dangerous if there's a lack of oxygen. And then second is excessive carbon dioxide. So as you remember, carbon dioxide can displace oxygen. So it's that surrogate gas, right? So an excessive amount of CO2 will drive and displace that process upon which the O2 is existing in that atmosphere. So definitely something that you should be very concerned about. And then hydrogen sulfide, excessive hydrogen sulfide, this can be dangerous as well because your body does not respond to hydrogen sulfides very well. Definitely can cause you to become incapacitated and have respiratory concerns as well. And then finally, the last is excessive carbon monoxide. So as you remember, this is kind of one of the areas that is of most critical because as you know, there's no short-term exposure limit. The ceiling, you really do not want to be exposed to carbon monoxide. It's very dangerous. And certainly if you're working in a work-based scenario, you're working in any confined space and carbon monoxide is present, please keep this in mind. An APR is not going to help you. It can actually create more problems because you're getting even less oxygen you're breathing in as you're working with an APR. So you need to have that scuba-based system to make sure that you are going to be safe from this. So on to slide 8. Okay. Let's go back to slide 7. Slide 8 is useless. So with slide 7, again, keep these in mind that these 4 pieces are really what you're going to be considering when dealing with confined workspace. So with the lab, what I'm going to have you do is just write something up in regard to potential for confined workspaces. Where might you run into these things? And you can use some of the examples that I talked about with this lecture currently, and definitely keep that in mind. So if you've worked in a space where you had to provide oxygen for the people working in that space, let us know. Write about it. Tell us a little bit about it. But I'm looking forward to your lab. And again, you're all doing a wonderful job in the class. I appreciate that everybody's watching the videos. And keep up all the hard work. Make sure that you are well prepared for your paper and your presentation, your essays. Certainly any upcoming tests will be essay based, and I know that you all put a lot of work into your writing, and I continue to be very impressed with all the efforts that you're putting into this class. I'm grateful for that, and certainly keep your questions coming. You know, I know that a lot of you have been asking me some great questions in regard to the lecture material, and I would encourage you to continue to do so. But hopefully everyone's doing well and is moving through the semester and enjoying this process, and certainly are prepared for things to come. So keep that in mind, that we definitely will continue in this fashion. The reason this lecture is so light is because I really want you to focus on your paper and your presentation. Ask me questions about it. You know, if you want to know a little bit more in regard to what you should be writing about, I think it's been pretty straightforward. But if you have questions, definitely reach out to me and let me know your concerns. And with that, have a wonderful week, and I'll see you next week. But we'll correspond with you through your questions at william.vandyke@csusb.edu. A handful of you still have not provided me with your lab from last week, so as you remember, you're required to tell me what you are going to be writing about and presenting about. So make sure and get that information to me as soon as possible. If you do not see a score for that specific lab, which I believe is lab 7, that means that you have not provided me with that information as of yet. So thank you so much, and have a great week.